With every new discovery, the universe challenges us. Even with today's technological advances, there are still plenty of blind spots in the microcosm. The physical phenomena occurring in the most remote corners of the galaxy are not studied either. They can both terrify and amaze deep space researchers. Today we are going to tell you about one of the most powerful magnets in the universe, which has a truly colossal level of radiation, the magnetar. Over the past 50 years, mankind has several times encountered phenomenal radiation coming from distant regions of space, and, as is often happens in the case of space discoveries, astrophysicists did not immediately manage to identify the source. 1979, 3 American Vela satellites monitoring nuclear tests on the ground detect an unusual gamma-ray burst. 1992 astrophysicists suggest the existence of a celestial body, unknown to science, with a huge electromagnetic radiation coefficient. 1998 a flash, the constellation of the Eagle. Many measuring devices record an unexplained anomaly, the source of which is tens of thousands of light-years away. 2004. All the world's telescopes are briefly blinded. In less than a second, a wave of gamma rays passes through every square centimeter of the solar system. A wave of gamma rays passes through every square centimeter, the largest flare ever recorded in the history of observations. But today, we are as close as we can get to finally explaining the nature of this discovery. A magnetar is a neutron star that has an incredibly strong magnetic field of about 10 to the 13th power of Tesla, which is almost 1 trillion times greater than the electromagnetic radiation of the Earth, and it is one of the rarest and most dangerous phenomena humanity has ever encountered. When a supermassive star comes to the end of its life, a supernova explodes, and among the many scenarios, there is only one in which the star can become a magnet. Probably each of us has heard of Russian roulette. At least once in our lives. Russian roulette. According to the rules of the game, there is only one cartridge in the revolver drum. The probability that it will fall out when the trigger is pulled is extremely small, but when it does, the consequences take on a truly incredible turn. However, the debate among scientists about what this variant is still rages on. According to the first theory, the formation of a magnetar is influenced by the internal energy of the star and its rotational force. If a neutron star appears at the moment of rapid rotation, the internal energy of such a star and the force of its rotation, which has a huge impact in the first several seconds, together create a powerful magnetic field. In science, this process is called an active dynamo, but there is another theory. As a result of the accretion process, a magnetizer can receive energy from another star. Researchers have discovered a moving magnet that will leave our galaxy in the future. Most of the moving stars we know acquired their trajectory as a result of a supernova explosion in a binary system. This means that between two stars in such a system that have a common center of mass at the moment of rotation, the accretion process occurs. The material of one star gradually flows to the other. In this case, the potential magnet receives its own energy source. It's a bit like a basketball bouncing around a ring. Sooner or later, it will fall, but the process of rotation will determine the direction of this fall in advance. Magnetars spin very fast around their axis. Their speed ranges from several tenths to several thousand revolutions per second, while their size is recorded small. As a rule, the diameter of magnetars reaches only 20 to 30 kilometers. For comparison, the diameter of the Moon is 3,474 kilometers. That is about 173 times larger than an average MAG and ETA are. However, everything is much more complicated with mass. Magnetars with a radius of 15 kilometers, despite their size, will be much heavier than our Sun. It is believed that it is its extremely strong internal density that causes high magnetic radiation, for example, 1E1048.1 to 5937. The anomalous X-ray pulsar is located 9,000 light-years away in the constellation Cygnus. The star from which the magnetizer was formed had a mass 30 to 40 times that of the Sun. The density of material on these stars is so high that a ballpoint pen cap would weigh billions of tons. If a person were on the surface, they would be flattened in a matter of seconds. A few years ago, an astronomer from NASA managed to record a phenomenon that went down in history as ahistory as a shock star thanks to the Fermi Space Gamma Ray Telescope. Scientists received data on the most powerful bursts of X-rays, the source of which was the magnet SGRJ 1550 to 5418. The magnetic field of the star is so large that sometimes faults occur in its crust and a huge amount of energy is released. Such a star shock generates a pulsating electric current. Theoretically, if such a magnet at the peak of its activity were within the solar system, we would not even have time to notice the threat. The Earth's ozone layer, along with all forms of organic life inhabiting the planet, would be wiped out within a few hundredths of a second. Fortunately, the nearest magnetar is at a fairly safe distance from us. However, it is impossible to approach a magnet not only because of its gravitational properties, its core and energy outbursts during the period of starquake. At a distance of hundreds of thousands of kilometers, its magnetic field in its stable state can disable electrical appliances, and any object closer than 1,000 can be split into atoms. Today, among billions of neutron stars from various sources, we know from 30 to 150 potential magnetars. In the Milky Way, there are about 12 of them, and the nearest one is located at a distance of about 13,000 light-years from Earth. The magnetar is a source of soft gamma-ray bursts, and in the event of a star shock threatens us only with slight changes in the upper layers of the ionosphere due to the small size of magnetars and their distance from the Earth. It is impossible to observe such stars with conventional amateur telescopes. To study them, infrared or X-ray sky scanning is most often used. However, due to the fact that they emit an intense magnetic field and radiation, detecting these stars with instruments is much easier. And just such an event happened a few years ago. In 2013, astronomers announced that they had found a magnetar that is close to a supermassive black hole right in the center of the Milky Way. The star was discovered thanks to several orbiting telescopes, including the JustSpace X-ray Observatory. This magnet is located at a distance of only 0.3 light-years from the edge of the black hole, and to date, it is the only neutron star that has been detected near an object of this magnitude. The lifespan of a magnetar is not very long, only about 1 million years, and the attenuation of the magnetic field during its existence is quite natural. Some scientists suggest that such processes can lead to a change in the status of the star. In this case, magnetars can change their class, flare up more often or less often, deplete the supply of matter, which means moving from the SGR to AXP category. At the end of its existence, a star which was once a magnetar, but has experienced the decay of its magnetic field, it may then become a thermal neutron star. So far, there are only about 7 of them, and perhaps each of them was once one of the most dangerous objects in deep space. But to find out, we will need many years, technological improvements, and people who are willing to spend their lives searching for solutions to the most dangerous and incredible mysteries of the universe. If you like this video, please subscribe to our channel and like it, and see you soon.